the key to answering question 1, part 1, is understanding, first off, what's happening to the function inside the logarithm. So in part 1, we're interested in understanding the function x plus 1 squared plus 8. So my inside function is equal to x plus 1 squared plus 8. X plus 1 squared plus 8 is a function that is centered at -1, 8. Like this. And so that is that. The inside function is this quadratic. And so the range of the domain of the inside function is -infinity to infinity because it is a quadratic, and the range of the inside function is from 8 to infinity because it opens upward and starts at 8. So now, if we're looking at the log function, log base 2 of something, well, that's defined whenever that something is on the inside of the log base 2 is greater than 0. But our range of the x plus 1 squared plus 8, the inside function, is always greater than 0. So our domain for the function is all real numbers because no matter what x value I plug in, I get something in the range from positive 8 to infinity. So our domain is all real numbers. Our range is going to happen from from the value when our inside function is 8 to the value when our inside function is infinity. So that's going to be from 3 to infinity. And we include 3 because 3 is included in the range of the inside function. So our domain is all real numbers. Our range is from 3 to infinity. And if we are graphing our function at -1, 3, we get the value that of plugging in -1 gives us on the inside function just 8. Log base 2 of 8 is 3, so that's why we have this value. And then it's going to follow the basic shape of a logarithm leading away. So that is the graph of the first function. For our second function, we are looking at an inside function of -x squared plus 4x plus 5, which I can take that inside function and if I factor it, I get negative x minus 5 times x plus 1. So our inside function is a downward opening parabola that is from -1 and 5. So it looks like this. That is only positive between -1 and 5. So the domain of b of x is -1 to 5. I do not include -1 or 5 because those points would be 0. And if I plug the log 3 of 0, that's not defined. To find the range, I look at what happens as I get close to -1 and 5. And in both cases, I'm getting close to 0 on the inside function, which means my range is going down to -infinity. And then I need to know the top point where this inside function gets. And so this inside function gets to, well, I want the midpoint between between 1 and 5, so that's at 2. If I plug 2 in, I get -4 plus 8 is 4 plus 5 is 9. So this point is 2, 9. And so the highest value that the log base 3 could have on the inside is a 9, and log base 3 of 9 is 2. So it goes as high as 2. And so if we plot our graph at -1, at x equal -1 and x equal 5, we have vertical asymptotes because we are going to negative infinity at those points. And at 2, we hit the point 2. So it goes through that point 2, 2. And so our function looks something like this. For part 2, we want to see if the graphs of log base 2x plus 3 and 3 minus log base 2 of x minus 1 intersect. So to figure this out, all we have to do is set them equal to each other. So we say log base 2 of x plus 3 is equal to 3 minus log base 2 of x minus 1. And if I add log base 2 of x minus 1 to both sides, I get that 3 is equal to log base 2 of x plus 3 plus log base 2 of x minus 1. Using the rules of logs, I get that 3 is equal to log base 2 of x plus 3 times x minus 1, or 3 is equal to log base 2 of x squared plus 3x minus 1x is plus 2x minus 3. So if I take and I raise 2 to both sides of this equation, or take the inverse of log base 2, which is raise the 2 to the exponent of both sides, I get that 8 is equal to x squared plus 2x minus 3. So 8 is equal to x squared plus 2x minus 3. If I subtract 8 from both sides, I get x squared plus 2x minus 11 is equal to 0. And now we can use our quadratic formula to get x is equal to -2 plus or minus the square root of 4 minus 4ac, which would be plus 4 times 1 times 11, so plus 44, all over 2a, which would be divided by 2, and that is equal to -1 plus or minus, so I get 2 times the square root of 12 over 2, which would be equal to -1 plus or minus 2 root 3. Now, if I look at -1 plus 2 root 3, that works. But if I look at -1 minus 2 root 3, this is less than 0. So I can't plug -1 minus 2 root 3 into the log base 2 of x minus 1. So this is an extraneous solution. So the actual answer is x equals -1 plus 2 root 3. And that is the only place where they intersect. Okay, now let's look at part 2. So 7 raised to the log base 7 of 8. The 7 and the log base 7 are canceling each other out, so that's just 8. Log base 4 of 1 over 32. Well, I can write 32 as 2 to the 5th. So 1 over 32 is equal to 2 to the -5th. And if I'm looking at, but my base is 4, not 2. So to fix that, I have to do 4 to the 1/2. That gets me 2 to the -5th. But that's just equal 4 to the -5/2. So B is 5/2. If I look at C, I'm looking at 16 to some power to be equal to 2. And if I try to figure out what that is, well, 2 to the 4th is 16, so 16 to the 1/4 would be 2. D, the log base pi of 1. Well, the log base anything of 1 is just equal to 0. E, I'm looking at log base 10 of the cubed root of 0.01, which I can write as 0.01 to the 1/3, which is just equal to 1/3 log base 10 of 0.01. Log base 10 of 0.01 is -2, so this is equal to -2 times 1/3. Okay, so I have that log base A of 16 plus B is equal to 0, or log base A of 16 is equal to negative B, which I can rewrite as A to the negative B is equal to 16. Similarly, from plugging in the other equation, I get the other point, the 2, -1.5 point. I get that log base A of 2 plus B is equal to -3/2. And that I can simplify by saying log base A of 2 is equal to -3/2 minus B. This means that A to the -3/2 plus B is equal to 2. Now, I want to take both of these equations and rewrite them both in terms of A to the B. So if I write this first equation, A to the B is just equal to 1/16. The second equation says that A to the 3/2 plus B is equal to 1/2. Or A to the 3/2 times A to the B is equal to 1/2. Or A to the B is equal to 1/2 times A to the 3/2. Now I have these two equations. I can combine together to get 1/16 is equal to 1/2 times A to the 3/2. If I multiply both sides of this equation by A to the 3/2 and by 16, I get A to the 3/2 is equal to 16/2, which is 8. So if A to the 3/2 is equal to 8, it means that A is equal to 4. Now that I have that A is equal to 4, I can use this equation to say that A to the negative B is equal to 16. So 4 to the negative B is equal to 16. And 4 squared is equal to 16. So negative B must be equal to 2. So B is equal to -2. Those two are my answers. A is equal to 4, B is equal to -2. Question 3 says that a certain radioactive isotype has a 1/3 life of 4.3 seconds. 5 ounces remains after 12 seconds. So how much was present when the experiment began? So to start, we need to just write a formula. the amount that's present at time t is going to be equal to the amount that is present at time 0 times 1/3 raised to the t over 4.3 seconds. This is just the general formula for exponentiation. This is the exponential growth formula. So now we know that A of 5 is equal to 5 ounces. Sorry, A of 12 is equal to 5 ounces. So if A of 12 is equal to 5 ounces, we know that 5 is equal to A sub 0 times 1/3 raised to the 12 over 4.3. Or A0, our initial amount, is equal to 5 divided by 1/3 raised to the 12 over 4.3. And that is your answer. Now, part 2 of this question, we're using the same kind of ideas. This time we have some kind of a petri dish. It has at time 5, after 5 minutes it has 200 cells. After 35 minutes it has 3,000 cells. So in 30 minutes we went from 200 to 3,000. So we went up by a factor of 3,000 divided by 200 is equal to 15. So every 30 minutes we increase by 15 times. So our function should look like the number of cells we have. A of t is going to be equal to some initial amount, A sub 0, times 15 raised to the t minus 5 over 30. Every 30 minutes we go up by 15 times. So if we started with 200 cells at 5 minutes, then at 35 minutes we have gone 200 times 15 to the 30 minutes over 30 minutes. That's how much time has passed. Or 200 times 15 is 3,000. After 45 minutes, which is what we're after, it would be 200 times our multiplication factor of 15 raised to the 40 minutes over 30, or 200 times 15 to the 4/3. Now, if we want to know the initial amount, we would be looking at our starting quantity, which would be A of 0, would be equal to some 200 cells times 15 to the t minus 5 would be negative 5 over 30. So this is equal to 200 divided by 15 to the 1/6. And that is your final answer. So our final answer here, and our final answer here. That's how we do all of these problems.